In this session we shall see the processing of auto-level survey data. As the main screen opens, use File menu to select Set Working Folder. Next, select Folder Work located on the desktop. Next, select Menu Item File, then New Workspace Design and then New/Open Survey Application. Processing of auto-level survey data. As the workspace opens, select Tab Auto-Level. The current selected tab is Create Project. For processing users' data, user needs to click on button New Project, with the project name say, Job Number 1. The project folder will be created inside the working folder as Work, Survey Applications, Survey with Auto-Level Data, Design Job Number 1. Next, user will be asked to select the user's auto-level survey data file. A copy of the file will be brought into project folder Design Job Number 1 to process. Click on button Open Tutorial Example Data. As the message comes, click on button OK. The folders will be created inside the working folder as Work, Survey Applications, Survey with Auto-Level Data, Tutorial Survey with Auto-Level Data, and a copy of the auto-level survey data file survey.txt will be brought into working folder Survey with Auto-Level Data to process. The data in the auto-level survey data file must be made available in the following format and saved as a text file, for example survey.txt, which can be opened in Notepad. The auto-level data contains shenages at a regular or constant interval. The distances on the cross-section on either side of the center point 0.0, left side in negative and right side is positive, and the elevations, z, at all distances on either side of the center point. The data do not have easting, x, and northing, y, at these points where, z, is available. So, to get easting, x, and northing, y, at these points an alignment is to be defined, which passes through the center point at 0.0 of each cross-section. Referring to this alignment, the program will obtain the x and y coordinates of each point on the cross-section. This helps in making triangulation, digital terrain model, and finally the contours of the ground. Only the survey base plan drawing by digital mapping will not be created from ground model, which needs total station data for reading various features like houses, drains, electric poles, boundary walls, etc. on the ground. The alignment passes through the center of the cross-section, thus alignment becomes the center line of the survey. Alignment is defined and created as Halen, which means the horizontal alignment. This is important to be noted that the shenage intervals in auto-level survey data and in Pro-Halen or Halen data must be exactly same. User has to create the Pro-Halen data to create the Halen data. Pro-Halen data is created by following the data format. User may refer to relevant section of help in the main screen of Heads site, at Path. Help Contents Users Module Major Options of Heads Principal Major Options Pro-Heads Pro-Halen. The Pro-Halen data mentions the start shenage SC, shenage interval IN, default radius of curve for all intersection points, and then by writing with major option number 212 with easting, x, northing, y, and curve radius as a record line for each intersection point. In case the radius is not given, in all 212 records, then default radius will be taken. Processing of auto-level/digital level survey data. Next, select the tab Survey Data. Under this, the tab Horizontal Alignment is opened. Pro-Halen data is displayed by default. Option Process Pro-Halen data. To create Halen data is selected. Click on button Proceed. The process dialog box comes with various data for the tutorial example. Click on button Proceed to create Halen data. The process dialog box comes. Click on button Proceed. As the process finishes, the message comes. Click on button OK and then Finish. The Halen data as created is displayed automatically on the left panel of the workspace. The option selected as Process Halen data. click on button Proceed. Click on button Proceed. As the process finishes, the message comes, click on button OK and then Finish. The alignment of the center line is created as string M001 under Model Design with start Shenage 31,150.0 meters with Shenage interval as 5.0 meters, multiple of 25.0 meters of Shenage interval in the auto-level cross-section data. Click on buttons View Halon Design, Shenage on and Details on. The alignment with Shenage and eyepiece curve details will be displayed. Ground Modeling. Next, select the tab Ground Modeling, click on button Create Ground Model. The process dialog box comes with ground model name as ground and cross-section string label as M001. Click on button Proceed. The Auto-Level Data Type selection box comes. Click on button Auto-Level Data Type 1. The auto-level data types are described in User's Manual and Main Screen Help. As the first process dialog box comes, click on button Proceed. As the process finishes, the message comes, click on button OK and then Finish. This formats the auto-level data into DGM format. Next, the second process dialog box comes, click on button Proceed. As the process finishes, the message comes, click on button OK and then Finish. This processes formatted auto-level data from file crosssec.dgm file along with the alignment and creates the cross-section survey model ground and string G001 for the cross-section and also model ground and string GLST for the long section, by taking the Shenage and elevation from auto-level data at 0.0 distance in each cross-section. An enlarged view of any desired location can be viewed by using Zoom In, Zoom Out and Pan icons buttons at the top of the drawing window. Triangulation. Select tab Triangulation. Select all the survey features by clicking on button Select All. Next, click on button Create Triangulation Model. The dialog box comes to start the process. Click on button Proceed to process for triangulation. As the process is over, the message comes, click on button OK. The files HDS001.fill, HDS000.fill and contour.fill are created in the project folder. Contours. Select tab Contour. The model name, string label, and increments for primary, secondary and text are set with default names and values. If the ground is of flat nature, then user has to reduce the primary contour increment as 0.5 or 0.1 to get contours for the relatively flat ground. The secondary contour increment is always 5 times of increment of the primary contours. Texts for contour elevations are displayed on the secondary contours. Click on button Create Contour Model. The dialog box comes to start the process. Click on button Run. As the contour window opens, primary C001, secondary C005 and elevation text ELEV strings under model contour are created. Click on button Save, located at the top bar. Next, select yellow color icon for contour from bottom bar of the screen as shown and click on button Quit to close the contour window. Next, we are back to the workspace once again. Click on button Draw Contour Model, to draw the contour model and the contours are displayed. This is the end of the session for processing of auto-level survey data along with creating the center line alignment. Next, ground model, triangulation to create digital terrain model, DTM, and contours.